Thank you all for coming today. My name is Mike Hyland. I'm a fourth-year PhD student here at Northwestern in the Civil and Environmental Engineering Department. And today I'm going to be discussing a very exciting new technology, driverless vehicle fleets. Specifically, how one would manage a fleet of shared driverless vehicles. So those of you not familiar with this term, it's essentially Uber or Lyft, but without drivers in the vehicles. So I'm going to begin by contrasting our current transportation system with one potential future transportation system across two dimensions: who owns the vehicle and who operates the vehicle. So in our current system, obviously humans like you and I are the ones that have to drive the vehicle. And for the most part, vehicles on our road are owned by individuals or families. Now in this potential future transportation system, the vehicles will be operated by a computer or robot. And rather than individuals owning vehicles, for the most part, vehicles will be owned by third-party private companies that provide transportation services with those vehicles to humans like you and I. Now there's over 30 companies right now that are in the process of developing these vehicles, and most of them, at least initially, plan to provide transportation services with them rather than selling them to individuals. Now there are a number of potential benefits of shared driverless vehicle fleets in terms of both who owns the vehicle and who operates the vehicle. So in terms of vehicle ownership, the biggest potential benefit is lower overall transportation costs. So yeah, while that vehicle is going to cost more, that is the self-driving vehicle, is going to cost more than your regular sedan, you're going to be able to split or share that cost amongst a number of other people: the purchasing cost, the insurance cost, and the maintenance cost. So initial estimates suggest that between 5 and 20 individually owned vehicles can be replaced by a single shared vehicle. Now what about the benefits of getting the driver out of the vehicle and into the passenger seat? So the one big benefit is productivity. So rather than wasting 15 minutes or 3 hours every day driving to and from work, to and from the grocery store, or running errands, we can now spend this time reading, sleeping, watching movies, and now we can even safely send text messages and make phone calls when we're in the car. Which brings me to my last point, and this is the biggest and most important potential benefit of driverless vehicles, and that is in terms of safety. So every year in the United States alone, 33,000 people die in traffic accidents. Moreover, and this is very important, 90% of those accidents are the result of human-caused error. So simply by getting the driver out of the driver's seat, there's a potential to save up to 30,000 lives each year just by getting the driver out of the driver's seat. Now obviously getting to this future transportation system and capturing its benefits is going to be an enormous research and development challenge. There's going to be legal challenges, political challenges, even psychological challenges, and engineering challenges, of course. My research focuses on one of these engineering challenges. Specifically, I'm looking at how to effectively manage a fleet of vehicles in order to properly serve passengers like you and I when we want service. So I'm going to use the word manage a few times, but what do I mean by this? That's essentially me or someone else programming a computer to tell the vehicles where, when, and how to pick up and drop off customers like you and me when we want to ride and we request it with our smartphones. Now, to give a little background on kind of the computational problem that I'm trying to solve, I'm going to go back to the vehicle routing problem, which has been around for over 70 years now. It's famous for two reasons, both of which I'll get into in a second. But first, I'm going to describe the problem. Consider the United States Postal Service. Every morning, a fleet of vehicles and a group of postmen and postwomen start at the local post office or the depot with the vehicles. Now, the goal of this system is to most efficiently and minimize transportation costs, that including fuel costs as well as labor costs of the postmen and postwomen, to deliver mail to each and every one of us. So this is the essential part of the vehicle routing problem. Companies like Amazon, UPS, and FedEx are also solving this problem on a daily, if not hourly basis. Now, the problem is famous for two reasons. First of all, it has a number of applications, not only in transportation, but across computer science and engineering. And the second reason is that it's a computationally challenging problem. In fact, it's what's known as an NP-hard or NP-complete problem, meaning that exact solutions, that is the perfect or optimal solution, cannot be obtained in a reasonable amount of time for large problems. So what researchers and analysts do is develop what's called heuristic solutions. These are non-exact methods to provide a relatively good solution in a reasonable amount of time. Now what's important to understand is that each of these companies develop their own heuristics for their own problem. So the United States Postal Service basically has the same group of houses they have to visit every day, whereas a company like Amazon has to serve customers varying on an hourly basis. Which brings us to the problem of routing vehicles to serve passengers in an urban area. So this is even more challenging. The biggest difference now to point out is that we're talking about passengers, not freight. So while your UPS box might not mind waiting in the back of a truck on top of 20 other boxes, or waiting on a porch, or waiting in a warehouse, humans like you and I are not going to accept this quality of service. This is actually one of the reasons why a lot of us don't ride transit, even though it's available. So that's kind of the problem that everyone in my field is solving right now, or at least looking at. I shouldn't say everyone. A large number of people are looking at this problem. What my specific research is looking at is how these companies such as Uber, Lyft, Google, Ford are making business decisions and how those business decisions will impact how they operate a fleet of vehicles. So one example of this is in terms of reservations. So right now, if you want to ride to the airport at 5 o'clock on Friday from Evanston, you have to essentially wait till around 4:30, 4:45 on Friday to look at your Uber app and then request a ride then. But what if you were able to request a ride the day or two before? So obviously this would provide benefits for you as the customer, but for the fleet operator, this is a challenging problem because they no longer can just send their vehicles out willy-nilly to pick up customers wherever the demand takes them. They have to make sure that vehicle's there at 5 o'clock on Friday. So it's likely that they'll probably increase the cost if you want to make sure the vehicle's there at 5 o'clock on Friday. So to recap, there's fundamental changes that are occurring in our passenger transportation system. No longer will humans have to drive the vehicles. Moreover, rather than individuals or families owning vehicles, third-party private companies will be the ones providing transportation service to you and me with those vehicles. My research focuses on developing computationally efficient algorithms in order to effectively manage a fleet of vehicles. So this drives down their costs. Assuming there's reasonable competition amongst transportation service providers, this should drive down the cost for you and me of transportation, which leads to a more efficient and more productive economy, and more importantly, you and I have more money to spend on other things. Thank you very much.